So to review this practice quiz question, let's walk through the steps of binary search. With this given array, we're looking for a target of 7. So we gotta figure out what the middle is. Our code, as you've seen last week, does low plus high divided by 2. So our low is 0, high is 9. Add those together, divide by 2, you get 4. Remember, you round down when doing integer division. So we check spot number 4. We guess and see that, we got 11. We ask ourselves, is 11 bigger than or equal to my target of 7? In this case, it is bigger than, so then we update guess to be guess minus 1. Our high index changes. We're eliminating this entire left side. Because for sure, if 11 is too big, then 13 is too big, 15 is too big, 17 is too big. We're making use of that sortedness in binary search. And so far, we've checked or compared 11 to our target. We visited just one number so far. Next up, since we updated our high value to be guess minus 1 to be 3, again, we add these up, high and low, divide by 2. It becomes 1. We've now visited 3. We ask ourselves, is 3 less than or greater than 7? Seems like 3 is less than 7, so now we update this to update our low index to be guess plus 1. Ta-da. Once more, high plus low divided by 2 gives us 2. 5 divided by 2, round down, becomes 2. We have now visited the element 4. Notice one mistake you may have made was mixing up indices versus elements at those indices. So we guess 2. Again, we compare. Is 4 less than 7? Yep, it is. So we got to update our low. It becomes 3. We do one final check with 7, right? At position 3, is 7 equal to 7? Yes. We've found our target. We visited these 4 numbers. It could have been not equal to 7. For example, in this sorted array, it could have been like 8 in there. We still have to check this 4th one in order to be sure that 7 is or is not in my array. So there's the answer to part 1. We visited 4 numbers, 11, 3, 4, and 7 in that order. So if you stare at this little animation, you can see the visited numbers are the ones that turn white. First goes 11, then goes 3, then goes 4, and lastly, we found our 7. Part 2 to this practice quiz question, what elements, is binary search going to be faster than linear search for this specific array? And if we walk through linear search, that's just doing, is it 0, is it 3, is it 4, is it 7, we still visited 4 numbers. Binary search visited 4 numbers, linear search visited 4 numbers. So in this case, they tie. This wasn't asking you, is binary search always faster? If that was the question, binary search is not always faster. If I was looking for 0 in this array, binary search would check like at least 4 things, I think 4 things. But linear search would find it in the first go. So it depends on the array that you're given, which search is faster. Practice this once more. You have now this array, and now you're searching for 27. So maybe take 2 minutes. I'm going to pause my recording. It's back on. So for this particular problem, I think the answer key shows us it with the little widget, this animation. So stare at it for a little bit. 11, 24, 30 is guessed, then we stop. So it should be 3 numbers. I think for the people that answered 4, you may have gone and checked position 7, and that's not needed because your high became bigger than your low. And once that happens, you know your answer is not in your array. The number is either like way too small, right? You've eliminated the answers where it would have been. You guessed position 6, and then we're out of luck. Another point I think you may have made a mistake on is when you get right there and guess 24, right? 24 is less than 27. So your low index becomes guess plus 1. So right when I guessed there, right, your next guess was 6 plus, sorry, go back again, watch it once more. As soon as it guesses 24, low plus 1 is 7, so, shoot, sorry, I'm messing this up. Be careful how you update your guess. This is my main idea. Okay, any questions? No? Okay, so going on to coding bat, we will be talking about, which one? Words without, ooh, the very last one, okay. So we'll talk about words without, and know that if you want help on got milk or got milk lists, my block 6 videos go over those 2 problems. So I'm prioritizing this one because I haven't talked about it just yet. Okay. So this time around, I'm going to model a different process of approaching these coding bat problems so that it prepares you for the FRQ portion of the AP exam. I'm not going to press this go button, and instead I'm going to use these given examples, and I'm going to play the role of computer in testing out my code. And once I'm pretty sure and I've come up with my own test cases and stuff, then I'll press go once to check over my answer. On the AP test, know that it's you don't get a go button. You don't get to test out your code. It doesn't give you a bunch of test cases and tell you whether or not they're right or wrong. You've got to do that yourself. So let's try doing that here. Approach this like a AP test FRQ. Given an array of strings, return a new array without the strings that are equal to the target string. One approach is to count the occurrences of the target string, make a new array of the correct length, and then copy over the correct strings. All right. I don't think this sentence would be on the AP test. This is just Mr. Simon helping you out. We can go with this method. So as I stare at this, I notice the return type immediately. I have to return an array of strings. So I will do that. Let's make a string array. Oh gosh, and I have to think about, okay, how do I declare these again? Let's see. They're objects, right? So I'm thinking, can I do like new string, and then how do I do the length? It's my memory is a bit fuzzy, so syntax. It'll come to me. And then down here, let's do like answer. I'm pretty sure I messed up on this part. Then here, return answer, for example. I'm not going to press go. Yeah. Let's say, okay, on the AP test, you're allowed to look up, like, I guess the College Board allows you to look up certain things. I don't know if they have some kind of tool to prevent that. But on the pen and paper AP exam and all previous years, they had a quick reference guide. This thing is your little cheat sheet that is given to you so that you have to memorize not every single function. If, let's say, I forgot how like dot equals works, for example, or substring, it gives you a little hint on how that works. I don't think it has what I need right now when declaring an array of strings, because that seems to have slipped my mind. So, but this would be useful. Let's say you forgot the syntax or the spelling for using array list classes. Like I used this when working on got milk list. That's totally legal. Okay, so we're back here. Cool, thank you. I'm a little bit hesitant on the syntax here. It's been a while, but I think it looks something like this. Right, then we'll follow the hint, count the occurrences of the target string. Okay, so if I'm doing that, I have to write a little for loop. This is based on the input array called words, growing it +1. Oops, wrong thing. Let's put that here. And then this part, I will then do some counting. If words at position I, remember you don't use the double equals for string comparisons. That compares memory locations. We need to use dot equals. When in doubt, working with strings and you're comparing, use dot equals. If that is equal to my target, that's true, then, ooh, looks like I need another variable to help me hold on to my answer size. So this thing shouldn't be up here. Let's move that like down here. So plus plus, that's the same as answer size equals answer size +1. Okay. So when we find our target in our words array, we grow our answer size, then down here, once we know our size, then we can make our answer array have the correct size. Cool. So make new array of that size, calculated size. Okay. Then copy over the correct strings. Looks like now we will write another for loop. This time around, it's going to do some copying. Let me type it out. I shouldn't copy and paste. Int I equals 0, I less than words. Yeah, words.length. I plus plus. And then now we look for things that are not equal to our target. If, not oof, if words square bracket I dot equals our target. Okay, if it's not equal to my target, so notice the exclamation mark, it flips our logic. Then we need to update answer. Answer in position. Ooh, okay, we got some funny things happening with the syntax, right? Because if it is in there, we have to like make sure it's like sequential in how it updates. So maybe we want to use another variable. There may be another more efficient way to do it. For me, I might make another variable up here that helps me keep track of where I am in my answer array. Is there anything special with copying? I don't think so for strings. It could be something important, like that. Remember to increment your temp. Okay, so I think this code accomplishes what I want. Let's test and see if this works. Go to my annotate tool. I'm not going to press go to do that. I'm going to play the role of computer. I'm going to walk through this test case. So my array is this thing with 4 letters inside, and A is the target. I'm not going to copy over these A's, which is why the output here is B and C. First, answer size is 0. Then words.length here is 4. I check the first thing, so I look here. Is this position equal to my target? Yep. So then answer size is right now equal to 1. I go next and check B. Is B equal to my target? Nope. So answer stays 1. Answer size stays 1. I go to C. I do the comparison. I don't grow answer size. I go to A. And in this last one, I do see that it is equal to my target. So let me go and update answer size to be 2. I finished calculating my how many occurrences there are. Temp is 0. Answer now contains 2 things, so it's ready. This is my answer array. Looks something like this. Okay, I want to write that out. Now we go into the second for loop. We still have to check through every single thing, so words.length is 4. Words.target equal, or this part, right? So when I look at these, I'm going to save this not and remember it. If I had a highlighter, I would highlight it. If I had a pencil, I'd circle it a bunch of times. Words at position 0, so that's over here. Is that equal to my target? And then you flip it. It is equal to my target. And then I do the opposite, so that's false. I skip it over. I don't copy it to my new array. Oh yeah, you got me. Yes, good point. So a student noticed that in this case it happens to work, right? My declaration of answer size here, but I should be actually doing words.length minus answer size, because right now it's 4 minus 2, both ends up being 2. It's okay, but if it were like 5 things inside and just 1 occurrence of my target, then my answer array should be 4, length 4. So good catch. The test cases that are given, that would have caught it when I was going to walk through this one right here, right? Sure. There are easier ways to go about it. This is how I'm walking through it right now, and I think it's okay. Yeah, you're totally right. Like the student's saying it might be easier for the first loop not to be not equal, so that I have my size. So then I could do that, but good catch. As written, this is one way to fix it. The other way would be to leave answer size here and then put the not equals up here like that. 2 ways to go about it to make it better. Where was I? So I'm doing these comparisons. I'm not copying over A at the moment because it is equal to my target. Then I go ahead and move to B. Is B equal to A? Nope. Flip it. This ends up being true. So temp becomes the letter B. Neat. and then temp grows by 1. I go check C now. C does not equal my target, yep, so then I copy the letter C here, and then I grow my temp, and I no longer do anything. At the very end, I return my answer. Nice, B and C, that matches up. If you were to walk through the second test case, you would have seen that if I left words.length not here, answer.size would be of the wrong size. That would be obvious. You would see that in this example. And then for this one, I guess it comes up once more, right? We should have a test case where, like in this example, I noticed that my target is always in my array, right? If I were testing this out some more on the AP test, I should give it something that looks like A, and then B, and then my target is like the letter C, for example. It should copy everything that's here. Another test case to address is what happens if my list was empty. The AP test loves checking for this. If I had at the empty array and I had like the letter B inside, if these were my inputs, would your code address it? And often this is like 1 point on the AP exam, testing these other things not given in the example test cases. The AP FRQs has a couple, so that it shows you how the function works, but it doesn't show you all of them. So at this point, I recommend on your own time to walk through these other test cases as I've demonstrated, and let's see if this answer is correct. Ta-da, it is. And if it were wrong, you would understand a couple more of these test cases, but try to play computer on your own. Test your code before pressing the go button. That's my tip. So that's all for today's class. Not the most efficient answer here, but surely one that works. That's all that's needed. Formally you're dismissed. Have a great Wednesday.